Imagine this. The most dangerous machine ever built by humans was not invented by humans at all. It did not emerge from secret laboratories. It was not born from war. And it was not guided by brilliant minds like Fermi, Oppenheimer, or Einstein. That belief is wrong. We tell ourselves that nuclear fire was the crowning achievement of the 20th century, a force unlocked through steel containment vessels, complex mathematics, and absolute precision. We believe nuclear power is artificial, that it cannot exist without computers, without control rooms, without engineers standing by. But in May of 1972, that certainty collapsed. At a nuclear fuel processing plant in France, a technician was performing a routine analysis. He was measuring uranium ore, mined from a remote region of Gabon in West Africa. The result should have been ordinary. Uranium measurements do not change anywhere in the solar system. On Earth, on the Moon, inside meteorites from deep space, the ratio of uranium-235 is always the same, 0.720%, a universal constant, a number physics depends on. But the sample from Gabon did not match. It read 0.717, a difference so small it could be dismissed as a rounding error. But in nuclear physics, there are no rounding errors. That missing fraction meant something terrifying. It meant the uranium had already been used. Moo, pa, moo. Was there a secret enrichment facility hidden somewhere underground? Investigators traced the shipment back to its source, a mine in a place called Oklo. When scientists drilled into the rock, the mystery deepened. They did not find one depleted sample. They found entire veins where uranium-235 was almost completely gone. Calculations followed. The missing material was not grams. It was 200 kilograms. Enough potential energy to build multiple nuclear weapons. Yet there were no stolen shipments, no facilities, no human fingerprints, because these rocks were 2 billion years old. The realization was impossible. The uranium had not been stolen. It had been burned, right there, inside the Earth, long before humans existed, long before dinosaurs, before complex life itself. This rock had turned itself on. It was a nuclear reactor, fully operational, self-sustaining, and it had run for hundreds of thousands of years. This discovery shattered the timeline of science. It meant nature had mastered the atom 2 billion years before humanity even imagined it. But how? How could a pile of stone achieve what took modern civilization decades of struggle to create? To understand this, we must travel backward in time. 2 billion years ago, Earth was a different world. The atmosphere was changing. Primitive bacteria were filling the air with oxygen for the first time. That oxygen transformed the planet. It altered the chemistry of the ground, making uranium soluble, allowing it to dissolve in water and move through cracks in the crust. At Oklo, conditions aligned perfectly. Rainwater rich in uranium collected in layers of sandstone. Over centuries, the metal concentrated into thick yellow veins. But concentration alone does not start a fire. You need a critical mass. Today, natural uranium cannot do this. The isotope required, uranium-235, has decayed over time. That is why modern reactors require massive centrifuges to force enrichment. But 2 billion years ago, the uranium was young, fresh. It naturally contained nearly 3% U-235, the same enrichment level used in modern nuclear power plants. Nature had created its own fuel rods, waiting. The final trigger was water. In human reactors, we use graphite or heavy water to slow neutrons down. At Oklo, groundwater did the same. It seeped into the rock, surrounded the uranium, slowed the neutrons. The chain reaction began. The rock heated, not enough to melt, but enough to boil the water. Steam surged through the cracks, pressure rose. And then something remarkable happened. As the water boiled away, the moderator vanished. Without slowed neutrons, the reaction stopped. The rock cooled, silence returned. Then the steam condensed, water flowed back in, and the reaction began again, on, off, a nuclear heartbeat. Scientists calculated the rhythm: 30 minutes of fire, 2.5 hours of rest, again and again, for hundreds of thousands of years. Not one reactor, but over a dozen zones spread across the region. A natural nuclear network buried beneath ancient stone. But the most humbling part of the Oklo story is not the fire, it is the waste. Today we fear nuclear waste more than the reaction itself. We build billion-dollar vaults to hide it. We worry about leaks lasting tens of thousands of years. At Oklo, there were no steel canisters, no concrete bunkers, no guards, only rock. And yet, 2 billion years later, the radioactive waste had barely moved. Most elements migrated less than a few centimeters, locked inside crystal lattices. Through earthquakes, through shifting continents, through the rise and fall of oceans, the poison stayed trapped until it decayed into safety. Nature had contained it perfectly. This forces a shift in perspective. We speak of saving the planet, as if Earth is fragile. Oklo tells a different story. The planet mastered nuclear fire simply by obeying chemistry. No control room, no warning signs, just balance. So why don't we see this today? Because time has closed the window. The uranium left on Earth is old, tired. The potent isotope has faded. We arrived too late. If humanity had evolved earlier, we might have found warm rocks glowing quietly beneath our feet. Instead, we inherit only the evidence. Oklo stands as a monument, a test conducted by the planet itself. It asks us a question: why are we so afraid? Perhaps the danger of nuclear power is not the process, but our impatience. We force reactions. We demand constant output. We refuse to let systems rest. Oklo took its time. It breathed. It paused. It left no scar. Only a riddle waiting in stone. The reactor is cold now. The water is gone. The uranium is spent. But the message remains, written in isotopes, encoded in rock, waiting for us to listen. This is Mynthera, where the past holds the keys to the future, and where the Earth keeps its own secrets.